This is part 2 of the launch of Think Factory Security, Peace and Policy Initiatives, SAPI in short. SAPI is newly set up think tank launched in October 2021 at the hands of Shri Shekhar Dutt, former governor and former defense secretary. Dr. Sivathanu Pillai, distinguished scientist of DRDO and founder, CEO and managing director of Brahmos Aerospace Private Limited, and Shri Arvind Gupta, director of Vivekananda International Foundation, who had been former Deputy NSA and DG IDSA too. It is the endeavor of SAPI to be a platform to create fresh grounds for cross pollination of ideas and deliver value to society in the field of security, peace, and public policy. In this part, Dr. Sivathanu Pillai is sharing his ideas and thoughts as keynote speaker on absorption of transfer of technology and how the same was achieved by Brahmos Limited.
So good afternoon, respected Sri Shekhar Dutt, former governor of Chhattisgarh, former deputy NSA, former defense secretary, and a champion of indigenization of defense equipment in the country. We call him champion of self-reliance. Sri Arvind Gupta, former DG IDSA and former deputy NSA, and presently director of Vivekananda International Foundation. Mr. Pradeep Gupta, the founder of SAPI, and his colleagues, distinguished dignitaries who are assembled, very renowned people I could see in my computer. So friends, good afternoon to all of you. I'm indeed delighted to be present in this inaugural webinar of the Society of the Security and Policy Initiative started by Pradeep Gupta and his team. It's a think tank factory. He calls it as a factory. Now itself he has started the production mind he has got. The two verticals chosen by him, really they have not been given enough deliberations. So it's a right decision from his side to choose these two verticals. That means he has got a focus now. This is a laudable initiative, and from his presentation, I could see that it is going to SAPI. Well, just we are putting the sapling today. It will grow in a big way, and I have no doubt in my mind that it is going to be a very good organization, a think tank group, which will give a lot of suggestions for the policy decisions of the government. So let me wish all success to this initiative. And we are with you to see that you progress, because we won't leave you now. Because we have initiated, we will be with you. I'm going to cover some parts of the technology transfer, as Mr. Gupta wanted me to talk about the dimensions of technology transfer, building a self-reliant India. See, India has progressed. Many people think that if we don't have technology, we don't do things properly, all those things. But if you just see 60 years of our progress, we are good in agriculture, Green Revolution 2 with 400 million tons aim. White Revolution, we are the largest producer of milk in the world, and we are giving the lot of emphasis on the power production, including the nuclear generation of power. Then computer was refused to us. Now we are making petaflop computer. Communication, we have grown in a big way. IT and ITS generating $220 billion. Pharma, we are doing very well. And in the defense also, if you see strategic missiles, and then our combat aircraft, and then Arihant, these are all very solid contributions. And there are many organizations, DRDO plus the industries. Then space, everybody knows space, we have done very well, and we are moving towards hypersonic. So this shows that India is moving in technology. Now, if you see the idea of Dr. Sarabhai when he started the space program, he chose a place Tumba, which is the only place in India where the magnetic equator is passing through. This is an attraction for many countries to come and do the experiment for sounding rockets to study the upper atmosphere. That means he wanted everybody to come to him. That was the thing. But his thought was, he made it very clear that India will be second to none in using advanced technology to solve the problems of common man. That was his focus. So his focus was society, how it will be benefited by the space program. We look at it, initially a lot of developments took place. He brought 3,000 young, including me, he got into the space program in 1969, and he brought a lot of good leaders from NASA and other who are Indians who are there abroad. He brought, so he just made it such a way that the experience and youngness, youth should go together in developing multiple technologies. But he knows that it is very difficult task. So what he has done is, he has brought in application first. So he borrowed a satellite, ATS-6 from America, and the site program, 2,400 villages were shown at the first time they are seeing in TV. In many places where the power is not there, he arranged the TV to be broadcasted. Then another program was STEP program, that is Symphony Franco-German satellite, which beamed communication to all the villages. So then people are very enthusiastic. There is an application of space program. So he put application by taking support from the other countries. Then the program also, he thought that he has to go for a big program. So he gave a 10-year vision document he prepared, where he wanted India should be capable of developing indigenous launch vehicle to put our own satellite and to give application to our people. All should be 100% indigenous, we should go. That was his aim. And that was the thing which started the space program. And you see space program today has grown enormously. Here, though Sarabhai initiated this collaborations with many countries, it is really the whole space programs and the department was built by Professor Satish Dhawan. So he built the institution. He was a mission-oriented person. All programs are mission-oriented, not cluttered with all the things. Then he had system approach, then strong leadership he gave, and nobility in the organization. He brought in new culture, he brought in the organization. The most important thing is, at that time when we started space program, industry was nowhere. He made industry connect. Funding in industry he did. Even private industries were funded by space department to develop the technologies. At the same time, technologies were borrowed. If you look at this side, the successful technology transfer, only 100% technology transfer, 100% I will say, it has happened only in Department of Space, in ISRO. Solid propellant, they did not develop the solid propellant. Initially, solid propellant came from SNP, France, but they have gone for all indigenous systems for SLV3. In the SLV3, propellants are totally indigenous. They built capability. Today, solid propulsion, if you take ISRO, 100% is monitored. You see, big boosters are being made. These GSLE Mark III boosters, they're all solid propellant with a 200 ton of propellant each. So we have got the capability to produce any, big boosters. Solid propellant, we are indigenous. Even small element of the combustion is we are getting only from our country. All the rest in everything. So it's a large investment has happened in the private sector, and they are like this HTBB resin, which is a very important thing for a solid propellant, is being produced by the industry. Now, second, liquid, they were not strong at that time. So Dhawan wanted liquid technology to come from SCP France. So he positioned 100 engineers. It was headed by Nabinarayanan, who headed that group. And 5 years they stayed there along with the SCP people when they were developing the Viking engine. Our people were there, and backup team was created in ISRO at Trivandrum. That was also 100 people. So they were taking immediately technology, and then all the French documents were made in English, and technology transfer was going between these 200 people, one side at near Paris, the Vernon, and other side at the Tumba. So you see that technology transfer mechanism, what has been evolved, was so thorough that when we have designed the PSLV, that the L33 Viking engine was not suitable, though we got the technology. Our people modified L37.5. Pressure was increased from 54 to 58.4. No, so all these modification means the whole thing has to be changed. But they were so thorough with technology, they could do it. Even the boosters of GSLV, 4 boosters are there. They're all L40 engines, L40 systems, which are totally indigenous. So they have taken the technology initially, but they have given a lesson to them that you can operate this engine at high pressure. So they did that. So it's a reverse flow took place in this case. Similarly, cryogenic technology from Russia, there was a big arrangement. They were working with them. They got all the drawings, materials, everything. It was going smooth, but the Americans have troubled us by saying MTCR, which is not relevant. But finally, the contract was closed. And what the Russians did, they gave material, they gave all the inputs, and then gave 7 systems to 7 total stages for GSLV. And the whole thing came, but these people, our people worked hard and completely upgraded the technology.
Please admit Mahesh Singla.
And you see, when we are going for this big cryogenic upper stage, it is not the one which the technology developed by the Russians. It has been developed by our people. So upgraded technology for GSLV has come indigenous. So you see the technology transfer here. This is the total absorption and development, new development which has taken place. So you say today we take the space program, they are self-reliant. That's what our topic is, self-reliant. We have achieved self-reliance in space technology. This is the GSLV, what you are saying it. This is the Vikas engine, not Viking, it's called Vikas. This is totally indigenous engine. And you are seeing the cryogenic engine developed indigenously by us. That goes on the 3rd stage, this goes on the 2nd stage, and all the strap-on boosters are all the same liquid engines. So we have mastered solid, liquid, and cryogenic propulsion systems in this. So we are now moving to human space program. There, these technologies are not sufficient, and so we have to make big boosters. So this needed a semi-cryogenic technology. This SE2000 engine, semi-cryogenic engine, has been developed under testing. So the people who have absorbed the technology, not only just repeating the technology, they have gone further. This is a big program space has done. So we have improved from this is the energy level, from 300 seconds when we say energy, kg second by kg, that is for solid liquid. Then we moved on to cryogenic. Then we moved on to solid ramjet in the case of Akash. Then liquid ramjet in the case of the Brahmos. And we are now working on scramjet. You see 3000, 10 times efficient compared to a solid propellant. We have reached that stage. Now, what we have done in defense? Technology transfer, we have done the Milan technology we have taken, and Bharat Dynamics, they are producing it. Then T-90 tank, we are technology transfer, we have taken Super 30, M21, all these things have taken. And no country will part the best technology to us, so we have got only the slightly downgraded and thinking about the input from them. Second-rate technology product is sold under license, recovering the cost spent on the development, controlled through spares and critical inputs. This is what happened. What we have got capability, we have built infrastructure, manpower, weapon delivery to armed forces we are doing, but indigenous design capability is lost. Spares still to come. We are ever dependent on the original supply. This was Mr. Gupta talked in the initial stage. So if you look at it, this is not the good way of transferring the technology and doing ourselves. What is the correct way of doing this? If you see the quality and value, there are two for any product. There's a value for the product, there's a quality product. These blue things are value. The curve which is being shown is the quality. Okay. The chain value chain comes when you have the design with you. When you have design, it jumps to 50% of the value of the product is design. Then process and manufacturing, what you are trying is 20. This is actual by experiment we have done and we arrived at these figures. So 70% is controlled by design and manufacturing. that is dictated by the effort, the skill level, knowledge level, what we possess. And in the quality, if you see, nearly 40% comes due to design, and another 30% comes through process and manufacturing. So this is also very important. 80, nearly 40%, about 70% comes from design and manufacturing. So you must know that unless you possess the design, you cannot give the correct quality, correct cost, and the correct producibility, the process, everything comes around the design. So knowledge is very important. So when we have started taking up the missile program, Dr. Kalam thought we should do 5 missiles, and then we should do everything up by ourselves, and our technology should be equal to what the developed countries have the technology. Contemporary performance at the time of deployment, though we are 30, 40 years behind them. And futuristic technology should be taught, newer concepts should become, and we should have a design adaptability for multi-user approach, and we should have a program management leadership to have 5 missiles simultaneously. That means we have to network with institutions for developing technology. Why we said that is, the reason is MTCR. So we thought we evolved a strategy, how to do it, for how to substitute, how to develop partners, then consortium, technology empowering, all those things we tried, and finally we could get all the technologies which were prohibited through MTCR, we combated, and then we got all the technologies in, for example, the re-entry, which is a very important technology for the Agni program, then sensors, guidance and control, then virtual reality for design, then operational systems, then processors, supercomputer, super components in 40 industries, and then in our own industries for for making the ICs and other components, then radar, phased array radar, multiple target engagement radar, and then propulsion systems, all have been developed by us with the partners from industry as well as institutions. It's a joint program. So technology denied is technology gained. Now, we are capable of doing the SAPI program. You know about the anti-satellite system. It has not just come. Everything has been channelized through the technology developed by us in the IGMDP. And then we have taken up the ballistic missile defense program based with Akash and Prithvi technologies. And then we achieved that 2-layer system and experimented. That has finally resulted into anti-satellite system. So India has begun powerful. All these are indigenous, totally indigenous capability we have built. Now, see parallelly the industry. Industry was originally thinking you give the drawing for manufacturing, we will do it. This we started with the NOC program. And finally, we found that industry was growing, and they are willing to evolve process and manufacturing. And then finally design to build strategy partner in Dhanush program. They have done everything. Now Arihant, so many programs you see, they are able to design from the specification. So the industry has grown over a period of time. 2010, I will say, the defense industry has matured. There are a number of public as well as private industries. And today SIDM, if you take the Society for Indian Defense Manufacturers, there are 500 members. So if you have grown to a very high level and people are capable of doing that, we have reached that level, both skill and competence has come. Now what is required to be done is this competence should be transferred to competitiveness. We should be a global player. The product excellence is very important for performance, quality and reliability. Newer technologies, quality procedure certification dictates the product excellence. And then cost effectiveness is continuous improvement of the product effectiveness. See, we should not stand with one product because as time goes, the requirement is very high, effective life cycle management, value engineering, cost control. So, and delivery in time, this is very important. You can make good things and then tell the world how you have developed. That's not the sufficient. What is important is you have to deliver on time as required by the user. So production infrastructure, trained manpower, contracts, ERP solutions, supply chain management, all have to be integrated in delivering the quality product on time. So we thought that instead of going through the regular approach, identifying L1 and going through the cumbersome process, we thought that we should make a private company out of government investment for the Brahmos program. So Brahmos is a joint venture between India and Russia. India contributing 50.5, Russia contributing 49.5. India having 50.5, it has become a private company because it is not 51. And then we have taken a big job of joint design, development, manufacture and marketing, a supersonic cruise missile first time. When no country has got supersonic cruise missile. People are working in hypersonic now, but they have not achieved what they required. Claims are made by Russia and China, but the real scramjet hypersonic missile for long distance is not there. But supersonic missiles are there. So supersonic is a very important requirement. And we had to work with the Russians because they have got the engine. And not only with the Russians, immediately we went for concurrent engineering. The day we started the program, we started identifying the industry. 220 industries in India have been identified for joint development with us, joint then production, with an assurance that if you develop, you will be the only production agency. Like that, we went for it. So joint design development, R&D and industry together, large scale industrial partnership. Industries put their money to develop, to build the infrastructure for production. It was not given by the company, JV, not by the government. Technology sharing came because the manufacturing of critical systems, which came from Russia, they were all produced in India. So common inspection standards were created. So we have seen the industries have grown and adopting themselves for the technology assimilation and doing that work. So this is one important development which has happened in the industry, in the defense. So you can see the number of industries involved, and the gain is 20,000 people full-time, they are still working for the Brahmos production. And we have established number of centers for production. Now 4 centers are working for production. And there are all these industries have gained a lot because the CSIR, the NCL, National Chemical Institute at Pune, they have made 130 rubber components which are required inside. And the whole thing is quality and making it more cost effective and producibility. All we looked at it and we have succeeded in this program. Today our Army, Navy and Air Force, they have Brahmos and they are all ready for deployments. So what is the Brahmos compared to Tomahawk of the Americans? Americans don't have the supersonic cruise missile. They have Tomahawk, which is 0.8 Mach number speed. They are 2.8 and target hit is 1/3 time. Kinetic energy is half mv squared. So 9 times we are having the energy at the time of delivery or hitting the target. Then the reaction time is quick because it's going quick. Enemy does not have much reaction time. Universality we produce, same system for sea and land targets. Salvo firing, 3 seconds every missile will go, and we could keep many missiles in a ship. All these things have been achieved and undefeatable due to speed, stealth, electronic countermeasures. And so we have seen that today in the cruise missile area, we are number 1 in the world. So this you are seeing a flight from Sukhoi. So the missile is dropped to a target 300 kilometers away, maneuvering, and finally it has to hit a target between around this point, between the 2 red points. The red points are the camera areas, camera points. Middle it has to hit. See, it is all 0 CEP. All the flights we have seen, we could hit the target. So speed, precision, and power, we have overtaken the developed nations. That is what we have achieved. I'm not claiming too much, it's a truth. So what we have done is investment $300 million jointly. That means $150 million from our side. and the production value now is 7 billion. We are going to have, we are having a target of 10 billion. Naval, Army and Air Force versions successfully completed within time, produced, delivered and operational. Indian Army is the only land force in the world to have a supersonic precision strike cruise missile. Universality, first time for multiple platform, multi-target and multi-mission achieved. So we have many versions we have got within short time, and this is a program jointly done by India and Russia. This is one model. So the whole thing is the concept can be leapfrog. So from the very beginning, we thought whether we can leapfrog. So leapfrog with whom? Leapfrog a developed country. We should become number one like that. Might to market brand, we have to evolve. So the points of synergy, innovation, leadership, and creativity. Innovation is speed, precision, power. Creativity is the concept itself is new and one step higher than state-of-the-art technology. Leadership is thinking ahead and managing the complexity with the multiple countries, 2 countries. And best practices, competency built up, then networking with stakeholders, all the industries are connected consortium. So the simultaneous production management setup, then we have made the world-class product. Technology, this is very important, technology sharing and resource pooling. Is the Russians have, many people think Russia does not give all the information, but we have not seen any problem with them. So because it's a joint venture, we have not taken technology transfer from it is a joint venture. It's a different way. So world-class product has been made, which is now highly demanded by the 3 forces. So what do we have now transferred by technology transfer, assimilation will have got conditions. So you will be still the importer. That's what is happening. So if you want to have in the zone of exporter, you should know why. You should innovate, you should do R&D, you should have design and development, you should have synergy through partnership. Then if you have got that, if you come to the green portion of it, then you become exporter. So skill and competence, both are required. We want to leapfrog and then come to the exporter area. So what we have finally, to sum up, what we have learned is there are 3 routes are possible. One is the license production, fabrication drawings, and the know-how. They say that they don't say everything. They give only manufacturing. They give, see MiG-21, you know the fate of MiG-21, limited know-how, high life cycle cost, spares have to come from them, industrial growth only in low technology area. But if we have got assimilated the technology, we would have made so many Sukhoi, we should not have bought, we would have developed equivalent to that if we had taken the technology in full spirit. Akash, it would be indigenous, we will do everything indigenously. We thought know-how, know-why and all there, but we have taken more time to develop. Repeated failures, R&D is, uncertainty is more. Low life cycle cost, all those things, but advantage, but still we have taken more time. So that is the B curve, it has taken more time. This is the A curve, the B curve. And route C is this, joint venture. So we have done it because of the 2 nation capability. We have assimilated the capability of the other nation to us. So that's how we have done. So these are the models which we should see. And what is needed for self-reliance is, we have a good vision, good government, different strategy for indigenous systems. Now being focused, procurement policy is very conducive for technology development and technology transfer and even for export. Offset policy is very good, but we should use the offset policy to our technology assimilation. And then if you look at the DRDO, high-end R&D collaborations are there. So joint ventures with the Russia, with Israel has matured enough, then that will give a base, technology base. Academy has to come forward in a better way. If this is a problem still, academy, we have given enough to them, but still it has not come to that expectation. Technology business incubators have to be created. Only IIT Madras has got a research park. which is doing very well on this, the developing new technologies. And IIT Bombay and IIT Delhi is coming next to that, IIT Madras. Academy should do high technology research, not focusing only on teaching. They should do research also. World-class laboratories should be created for developing new innovations. Then industry, R&D, technology transfer, absorption. This is a very important point, absorption. And globally competitive product they should make. Because the whole thing is now competitive world. They will get the wealth through export. So multi-industry complex, which was thought about, is slowly coming, but it should be defined very well. Still, we are focusing more on the PSUs, but now private sectors are coming. Things are changing now. And the government policies are more favorable. And FDI is aimed to get more technology products. So competitiveness, once you create, will become state-of-the-art military systems, and increased industry production will come. And then not only we do the self-reliance index goes up, we will also do export. So this is the vision with which we should approach. So thank you for giving me the opportunity, and I wish great growth for this think tank factory SAPI. Thank you very much.
Thank you, sir.